Hello. Endariki namaskaram. This is your Captain Shreyas, and we are going live on the VEDANTU JEE English channel for your EMSAT, EPSAT for Telangana and Andhra. Yes, for all those ultra legends who want to score at least 30 plus marks in the last moment with the most predicted, most probable, and most likely questions which can come in the days to come. Right? So yesterday we did a class on the 12th standard question. We solved many questions yesterday. So today we are going to solve the 11th syllabus. With me, your Captain Shreyas, who has been training kids for more than 13 years. And you know, I am a pass out from NIT Nagpur, did my mechanical engineering. I love physics. I almost scored full marks in my physics JEE attempt. And then I also did my research from IIT Bombay. So that's my quick introduction. I hope you have smashed the like button. And yes, I hope you guys are all ready and all fine. Miru ella unnaru. Yes, your captain is live. Hello Tagore, hello Surendra, hello Priya, hello everyone. Good morning. Nice to see all of you out here. So let's begin, everybody. Yes, ready for the session? Awesome. Let's go ahead. So let's start with the first question. Just one second, let me set up my chats properly. Yeah, okay, it's done. Yes, here is the first question. The power of a motor is 200 watts. If the unit of length is made half, the mass is doubled and the time is also doubled. What is the power of the motor in the new system? In such questions, first identify the dimensions, or basically find the dimensional formula of the given quantity, and then only try to solve the problem. The question is on power. So power, we all know, is nothing but work divided by the time. And work is nothing but force into nothing but displacement divided by time. Force is nothing but mass into acceleration, and that's it, divided by time. So what is mass dimensions? It is m raised to 1. Acceleration dimension is length raised to 1, t raised to minus 2. Displacement is L raised to 1, and the whole thing divided by time, which is over here. So eventually the dimensional formula will turn out to be, check this out, it will be m raised to 1. L's power is basically 2, and times power will be nothing but minus 3. That is the final dimensional formula. Now what is happening is the unit of length is made half. So length is made half times. So the square of the length will be made half square times half square, because length has been made half. So length square will be made 1/4 time. Mass is doubled. So the unit of mass is made 2 times. What about the unit of time? The unit of time is doubled. But time, remember, is there below. So technically, this is 2 raised to minus 3. Is that right, everyone? Everybody with me? The unit of the length is half, the unit of the mass is basically doubled, and that of the time is also doubled. Now when you do this, what is the number that you get? 2 multiplied by 1/4 multiplied by 1/2 cube is basically 8. So this goes with this. This will become 4 times. So this will become 1/16 times. This will basically become 1/16 times. Now you should understand whether the new unit is 1/16th or the old unit is 1/16th. You should understand that logic. Whether the new unit is 1/16th of the old SI unit, or the SI unit is 1/16th of the new unit. What do you think? Which is the case? What do you think? What is that case? Think about it carefully. Okay, I'll give you an example. The 1 unit of length as per this is halved. So basically the 1 unit of length is half times the unit, SI unit of length, which is basically in meters. SI unit of length, which is basically in meters. So 1 SI unit of length is 2 times is 2 times the units, 2 times the units in length of that new one, of that new unit of length. So similarly think in this particular problem, what should happen? What should happen? If I tell you the old power is 200 watts, old power is 200 watts, this is in SI. In the new unit, what should happen? If the length was halved, it becomes 2 times in the new unit. So same way, if it has become 1/16th, so it should become basically 16 times of this 200 in the new units, exactly. So it will be 3200 new units, which is, yes, the option B, Like I said over here, if the length has been made half, in the new units, it will become 2 times. It is exactly opposite. Okay, so a lot of people divide by 2 instead of multiplying by 2. So if I saw the factor by which the power changed was 1/16th, so actually in the new unit, it will be 16 times. It will be basically 16 times. Understood? Is that absolutely clear? This is the main problem which many students face. And I gave it to you with a simple example over here. The length was halved, so in the new unit, it will become 2 times. Okay, because you can see that number 2 goes over here, so it will become 2 times in the new unit. So same way, if the power has become 1/16th times, that means in the new unit, it will be 16 times more. That is the simple logic. Okay, let's move. Length of a pendulum is 100 plus minus 0.6. The percentage error in the measurement is how much? Now, is the time period of a pendulum related to the length? Yes or no? Quickly think about it. Yes, it is related. What is the relationship? The time period is 2 pi root of L divided by G. Is that right? So, the relative error in the time period will be, the power of length is half. So, it will be half times the relative error in the length. Now, check this out. The relative error in the length. The length of the pendulum has an error of 0.6 for 100 centimeters. So, that is your relative error in the time. But if I ask you percentage error in the time, measurement, what you will do is you will take this and just multiply by 100 to convert it into percentage. 100 cancels. It will become basically 0.3 percentage. So 0.3 is option number 1. Yes, that is correct. It is not 0.6 or anything else. Come on, quickly let me know in the chat box. Yes, post the answers. Don't stay silent. Sushant, if you are scared to tell my parents that I'm interested in dropper, I feel that you should confront them as soon as possible, because that is your desire, that is your liking, because you are going to stay with the degree, you are going to stay with the college tag lifelong. You will be living with it, not anybody else, neither your parents, nor your brothers, sisters, nor any of your friend or relatives. You have to live with that degree, with that tag, with that branch rest of your life. If you are not comfortable going to a particular college or a branch, you should definitely talk to your parents. Make them understand. Make them coolly understand. Don't fight. Coolly make them understand. Talk to them. Show them some videos and let them know. If in fact, you can also show this particular part of that entire clipping that sir is only telling. Okay. So if you really feel like taking a drop, you feel that there were some mistakes which you have committed and you can improve, please do not hesitate. It's perfectly fine to take a drop. There is nothing wrong in taking a drop. In fact, it is completely worth it if you have that patience, that desire, 100%. There is a body which is going in a circular path maintaining a constant speed. Then which of the following correctly describes the relation between acceleration and radius? Quickly, this is a very simple one. Come on. When a body is going in a circular path, the acceleration is the centripetal acceleration and the formula is v squared by r. So the centripetal acceleration is inversely proportional to r. So if it is inversely proportional to r, which is the correct graph, guys? inversely proportional. It can't be this, it can't be this, it can't be this. It has to be this one, of course. Let's find out. Yes, it is option number A. Let's see how many of you wrote A for Allu Arjun. Very nice. Very good. Very good. Kuldeep has written the correct answer. No, Soumya, it is not D. Yep. Very good. Awesomeness. Very good. Let's move on to the next question coming up on your screen. Here it is. The position of a particle is given by, it's in two-dimensional motion because I can see I cap and j cap. 15 t square I cap, 4 minus 20 t square j cap. What is the magnitude of the acceleration at t is equal to 1? That is the question. What is the magnitude of the acceleration at time is equal to 1? If I know position, to find acceleration, I need to differentiate it 2 times. First derivative will give velocity, next derivative will give me acceleration. So the velocity will be the derivative of the position vector, which is 15t square's derivative will be 15 into 2t I cap plus 4 is a constant, so derivative is 0, minus 20, t square's derivative is 2t, and then you have j cap. So therefore the velocity will be 30t I cap and 20 into 2 is 40, so 40t j cap. That is your velocity. Now what about the acceleration? Acceleration is the derivative of the velocity itself. So the derivative of 30t will be 30 only, and this will be I cap, minus 40t's derivative will be just 40, and that's j cap. So there is no involvement of time only over here. That's it. The question is find the magnitude of the acceleration. So if you want to find the magnitude, you take the x component, which is 30, square it, take the y component, which is 40, square it. Even if you take minus, the square will be positive. This answer will obviously be 50 meters per second square. And 50 is there as option number D. That is the correct answer. Wow, very good. So Kruti and so many others. Very good, Harsha. Very good, YouTube Fun. Yes, D option. Awesome, YouTube Fun. Very good, Sailekha. Awesomeness. Simple, right? There was no involvement of time only in this problem. Excellent. Let's move on. A particle of mass m is going in the x direction with speed 2v. It hits another particle of mass 2m moving in the y direction with speed v. Collision is perfectly inelastic, meaning they get stuck to each other. The percentage loss in the energy during the collision is asked. Let's try to figure out. So there is a mass m. It is moving with velocity 2v. There is another mass, and that is 2m, and that is moving with velocity v. This is before. After the collision, both of them together will become a mass of 3m, and it will have some new velocity. Let's say I call it as u. Now the good thing is, whether you take x direction or y direction, the momentum is going to be the same. You can see the momentum in the x direction is m into 2v. The momentum in the y direction is 2m into v. Here you can see px and py both are equal. So there are equal components of the momentum in x and y direction. Therefore, I can say that the final momentum will also have equal components. That means this angle will be 45 degree. It will have equal components in x and y direction. Why? Because initially also it had equal components, so finally also the components must remain conserved. So it will make 45 degrees with each one of them. So can I find this u? Definitely, why not? If you conserve the momentum in x direction or y direction, does not matter. In, let's say, x direction, conserve the momentum. Conserve the momentum. Obviously momentum always has to be conserved. Initial momentum is m into 2v. There is no momentum in x direction for the 2m mass, is equal to the final mass is 3m, velocity is u, but take the cos or the sine 45 component. Let's say I take sine 45. That would be the correct equation. That would be the correct equation, right? M will get cancelled. So I am just left with 2 times of v is equal to 3 times of u, and sine 45 is 1 by root 2. Therefore, my final velocity will be 2 root 2 divided by 3 times of v. that is your final velocity. But that is not the question. The question is the percentage loss in the energy. The percentage loss in the energy. The percentage loss will be nothing but the change in the kinetic energy. That means your initial kinetic energy was more, final was less. The whole thing divided by whatever is there initially, the whole thing multiplied by 100. That is your percentage loss. So we can do this very easily. Initial kinetic energy will be half into mass. The velocity was 2v, so 2v square, plus the second mass is also there, half 2m into v square minus final kinetic energy. So this is the speed, right? So half into 3m into this speed, which is 2 root 2 divided by 3 v whole square. The whole thing divided by initial energy, which is half into m into 2v square plus half into, this was supposed to be 2m, I'm so sorry. This is half into 2m. So half into 2m into v square, the whole thing multiplied by 100. Solve it and see if you get the answer as 56%. Solve it and see if you get it C for Captain Shreyas. That's all you need to do. Correct. Very good. If you solve this, you should get the answer as 56%. I hope you understood what we did over here. This part is nothing but initial kinetic energy, the kinetic energy of this mass and the kinetic energy of this mass, minus the final kinetic energy, that is of this guy. That will give me the loss upon the original. The original is the total kinetic energy before, into 100, because I have to find it out in percentage. That's all you need to do. Next question. A body is projected with some speed at an angle of 60 with the horizontal. The radius of curvature of the trajectory at 1 second is r, neglecting the resistance. Find the value of the radius of curvature. Okay, very interesting question on radius of curvature. Now remember, any curved path can be broken down into small arcs. So a curved path is made of an infinite arcs. Each arc will be a part of some circle. That circle's radius is called as the radius of curvature. So let's say the particle is projected like this. It had some initial velocity. How much was it? 10 meters per second, and at an angle of 60 degrees with the horizontal. So at t is equal to 1 second, what might happen? Let's find out. First of all, the velocity in the x direction will never ever change. Vx will always be equal to ux, so it will be always 10 cos 60. Cos 60 is half, so it will be just nothing but 5 meters per second. So that is your Vx value. It will always remain constant because since acceleration is not there in the x direction. What about the y direction? So Vy will be nothing but uy plus ay into t. Initial velocity in the y direction is basically 10 sine of 60 minus acceleration is negative 10, and the time value was nothing but how much? 1 second. Nothing but 1 second. So this is nothing but 10 root 3 by 2 minus 10, which is, you can take 10 common and this will become root 3 minus 2, the whole thing divided by 2. So 10 by 2 is 5. So it will become 5 into root 3 minus 2 meters per second. So these are the x and the y components of the velocity. These are the x and the y components of the velocity. That's what we got it. Okay. Why do we need it or not? We'll figure out. But understand, why did I find it out is because I understood that there is some x component, there is some y component, and over here root 3 is basically, lesser than 2. It's basically lesser than 2. So that means this value will be negative. So one thing is for sure, that this body after 1 second, probably it's going to be coming down. It's going to be coming down. So there will be some x component and there will be also some y component like this. So this will be the total velocity. This will be the total velocity. Is that right? Now what you need to do? Understand, this is going to be a part of some circle. I don't know which circle. It will have some radius. it will have some radius out here. It will have some radius over here. This is the center, this is the radius. Think about it. It will have acceleration due to gravity like this. It will have acceleration due to gravity like this. That acceleration will have two components. That acceleration will have two components, one here and one over here. This part is like the tangential acceleration. This part is like the centripetal acceleration. And we know centripetal acceleration is related to the velocity and the radius. I know centripetal is related to the velocity as well as the radius. Exactly my point. So I can find out, if I can find out this particular angle, and I know that centripetal acceleration is nothing but v squared divided by r. So my r will be v squared divided by your AC, and remember AC is going to be g cos theta. And what about final velocity? Well, that final velocity will be nothing but root of Vx square plus Vy square. Vy I know from here, Vx I know from here, I can substitute. What about theta? That's not a problem. I'll tell you why. Because if this is theta, even this is going to be theta, this is going to be theta, and I know very clearly from here, from this particular diagram, this is Vx, this is Vy. So cos theta will be adjacent, which is Vx divided by our final velocity. And our final velocity was root of Vx square plus Vy square, which we already figured out over here, right? So Vx square plus Vy square. So if you actually end up substituting, you know what you will get? Vx square plus Vy square, the whole thing divided by, instead of cos theta, I will be putting this, which is nothing but Vx divided by root of Vx square plus Vy square. So the root will just go away. And the radius will be Vx square plus Vy square, the whole thing divided by g. Now you know Vx, you know Vy, substitute, you will get the answer for r. Yes, you know the value of Vx from here, which is 5. You know the value of Vy from here, substitute it over here, you will get the value of r. Solving it, you get the answer as 2.8. Solving this, you will get the answer of r as 2.8 meters, right? So that is how you solve this. Question. Very nice question, but it will be deciding factor whether you are a topper in EAPCET or whether you are not a topper in EAPCET. Okay. A uniform cable of mass m is placed such that 1/nth part of it is hanging. To lift the hanging part onto the surface, the work done should be how much? Yes, Surendra, I am making you solve all kinds of questions so that anything comes, you are prepared for it. That's all. Okay. Now, this question you can solve it methodically, but shall I tell you an easy trick in the exam? How do you solve it? I'll tell you. See, as per the question, 1/nth part is hanging. 1/nth part is hanging and you have to lift it up. So let's take a special case. What is that special case? N is 1. That means the entire rope is hanging, because if N is 1/1th part, that means the entire rope is hanging, and then after some time you want to bring the entire rope onto the table. That is the catch, or that is the problem now. You want to bring the entire rope onto the table. Is that right? So in this special case, can you see that the center of mass was here, it has been brought over here. How much is the height difference of the center of mass? If the total length was L, won't this be L by 2? So what is the potential energy given to it? Change in the potential energy. It is the mass into G into H, which is mgl divided by 2. So that should be the work done. That should be the work done. Where do you get the answer as mgl by 2? By substituting n as 1. Substitute n as 1. If n is 1, this is mgl, so this is not correct. If n is 1, this is 2 mgl. This is not correct. Substitute n as 1. Here, if you substitute n as 1, it is mgl. This is also not correct. If you substitute n as 1, then mgl by 2, which is exactly what you are expecting it to be. So this is the correct option. Yes, perfect. So by substituting special case and without solving the problem, you can find the answers. You can find the answer. Got it, my dear warriors? Perfect. Very good, Akila. Awesome. 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 Very good. So these are the tricks which you can use in EMSAT, EPSAT, where you don't actually solve the question. And it is required. That is what toppers will do and save time. If there is a mass 2 kg makes a elastic collision with another body at rest and continues to move in the same direction but with 1/4 the speed, what is the mass of the second body? And it is given to be elastic collision. Always draw diagrams, don't write equations first. So it is a 2 kg mass and it is going with some speed, and there is another mass over here. What is the mass of the second body? I do not know, but it is given to be at rest. After the collision, what happens is, and continues to move in the original direction but with 1/4 of the speed. So this 2 kg mass continues to go with 1/4 of the speed of the original speed. So what will the other mass be doing? We can find that out. It is not that difficult. What is the mass of the second body? Because it is clearly mentioned that the collision is elastic, that means velocity of approach should be equal to velocity of separation. Is that right? So what is the velocity of approach? It is just u minus 0. This mass after the collision will be having some speed which I do not know. I am putting it as an unknown. What is the velocity of separation? Both of them are moving. So the relative velocity will be the subtraction, the difference of both of them. So v minus u by 4. So take the u by 4 over here. So v will be u plus u by 4. Therefore, v will be 5 times u divided by 4. But that is not the question. The question is find the other mass. So what I will do, I will conserve the momentum. Initial momentum is mass into velocity. Other guy is at rest. So 0 momentum for the other mass. This guy's momentum is mass into velocity, which is u by 4, plus mass into the velocity which we found here. That is why we found out over here, which is nothing but 5 times u divided by 4. 5 times u divided by 4. U get cancelled. 2, no, it does not get cancelled. So 2 is equal to 2 by 4 is basically half, and this will be just nothing but plus 5 times m divided by 4. Multiply by 4 both sides. 4 2s are 8. 4 by 2 is 2 plus basically 5m, right? Take this minus over here. So 6 is equal to 5m. So m is basically 6 divided by 5, which is 1.2 kg exactly. Just 6 divided by 5 kg, which is obviously 1.2. Got it? Option D. How many of you got option D? How many of you got option D? Awesome. Awesome. Very good. Very good. Awesomeness. Guys, make sure that you are not using this platform for chumma chatting over here. You have come here for studies, not for just chatting. Yes. Make sure that you are, focused on the session, or else the admin will be timing you out. Yep. Moving on to the next question. A body of mass 1 kg falls freely from a height of 100 meters on a platform of mass 3 kg, which is mounted on a spring having a constant of this much. The body sticks to the platform. The maximum compression is x. What is the value of x? So very straightforward. The height is quite large. The mass of the body is basically 1 kg and the height of drop is 100 meters. That is also quite lot. And it hits a platform. It hits a platform over here whose mass is basically 3 kg. Okay, the body sticks to the platform. The body sticks to the platform, and then it compresses the spring of constant 1.25 10 to the power 6 Newton per meter. Okay, so there are two chapters involved here. One is the collision part, second is the energy part. Because it sticks and it is an elastic collision, let's first find out the velocity with which this ball will even strike this particular mass. This u is nothing but root of 2gh, free fall motion formula. 2 into g is 10, height is basically 100. So this is going to be 100's root is basically 10, and 10 can be written down as 2 into 5. So 2 into 2 is 4, root of 4 is 2. So 2 into 10, that is 20 root 5 meters per second. That should be the answer. Just check this out. Is that right? 20 root 5, because from this 10, 5 into 2, 5 remains, 2 2s are 4. So root of 4 is 2. 100's root is 10. So 2 into 10 is 20. Okay, so that is the value of u that we got. Once I get the value of u, let's conserve momentum. So because of inelastic collision, it is sticking to it, right? The body sticks to it. So mass into velocity will be equal to the final mass will be 1 plus 3 kg into the final velocity. So u is basically 20 root 5 is equal to 1 plus 3 is 4 v. All right. So guys, over here, let me just solve this. What will be the value of velocity? 20 by 4 is 5. So it will be 5 root 5 meters per second. Is that right? 5 root 5 meters per second. But that's not the question. The question is now to figure out how much is the compression. How much is the compression? So just use the kinetic energy goes into the potential energy. Kinetic energy goes into the potential energy. So half into mass, which is 4 kg, into velocity, which is basically 5 root 5 whole square, is equal to half spring constant, which is 1.25 into 10 to the power 6 into x square. Solve this, you will get the value of x, and check if the value of x comes out as 0.04 meters. 0.04 meters, which is 4 centimeters. So after solving this, everything is known. Some of you will be like, sir, as the mass sticks and the spring compresses, won't the mass's potential energy also change? Answer is yes, but I will ignore it because the compression is so small, 4 centimeters, that the change in the gravitational potential energy as compared to the spring potential energy is negligible. So the change of the spring energy is much higher than the gravitational potential energy change. So I have ignored that particular part. Exactly. I have ignored that part. Very nice. Shall we go ahead to the next question coming up on your screen? Here it is. And I hope you guys are smashing the like button to show immense support for this channel for conducting your EAPCET sessions, your strategy sessions, hacks, cheat codes, chemistry, your physics, mathematics, all the mock papers, all the most predicted questions are being conducted over here. Even you can see our old videos which were there 2 years, 3 years back also. The first channel in the country to start the EAPCET classes. Let me tell you that 2-3 years back. The 3-point particles of mass 1 kg, 1.5 kg, 2.5 kg are at the 3 corners of a right angle triangle. Side 4, 3, 5 as shown. The center of the mass of the system is where? Where is the center of mass? So my dear students, over here, with respect to, I think 1 kg we have to find. So let me choose this only as the origin. Let me choose this as the x-axis. Let me choose this as my y-axis. This is your origin. So let us use xcm is m1 x1 plus m2 x2 like that upon m1 plus m2. So what is m1? It is 1 kg. What is the x coordinate of 1 kg? It is 0. So 1 into 0 plus m2 is 1.5. x2 is basically 3 plus m3 is basically 2.5. The x coordinate of 2.5 is nothing but 0. the whole thing divided by the total mass, which is 1 plus 1.5 plus 2.5. Is that right? That is your x coordinate. Same way you can also find your y coordinate of the center of mass. So m1 is 1 kg because it is at the origin, so into 0, plus mass number 2 1.5 kg, y coordinate is 0, it's on the x-axis, plus mass 3 2.5, y coordinate is 4, whole thing divided by the total mass, which is 1 plus 1.5 plus 2.5. That's it. You will get the y coordinate and the x coordinate. Just check out what is the answer that you are getting. 1.5 into 3, right? So that is going to be 4.5 divided by 1.5 plus 2.5, that is 4 plus 1, which is 5 over here. Same thing, this will be also 5 over here, and this is 0, this is 0. 2.5 into 4, that is basically 10. So this is going to be 2 centimeters. This is going to be 0.9 centimeters. So 0.9 and 2, 0.9 and 2, 0.9 on the right side, 2 above. So option A should be correct. Yes, option A is correct. Perfect. Perfect. We got it as option A. No, it is not option D. Be very careful, Akila. Okay, I think you made a mistake out there. Yes, it is option A. Sukruti, yes, correct. Yes, Trignak, correct, correct, correct. Perfecto. Awesome, awesome, awesome. Very good. Great. Very nice, very nice. Let's move ahead to the next question coming up on your screen. Here it is. What does it say? Wow, we have a drum disc and there is a thread and this mass is hanging and it is coming down. What is the acceleration? I have given a simple formula trick by which without solving the question you can solve it directly and give the answer. The way to solve it is to find the acceleration, write down the pulling force minus the opposing force, all these are forces on the top, upon the translation mass plus the factor multiplied by rotational mass, the factor in moment of inertia multiplied by rotational mass. You might be wondering, sir, what is all these things? I'll make you understand. See, it is very simple. When this drum is left, the pulling force is mg, nothing else. Opposing is not there unless there was another mass. This, let's say it is m2, so m2g would have been opposing. But here there is nothing to oppose. This drum is freely going to rotate. So there is no opposing force only. So the pull is simply put mg. Opposing force is not there only. Opposing force is not there only. Translating mass, which is the mass which is translating small m. So just put small m plus factor into rotating mass. Rotating mass is capital M. So put capital M multiplied by factor in the formula of moment of inertia. It's a disk. What is the formula? It is mr square by 2. What is the factor which gets multiplied by mr square? It is half. In solid sphere it is 2 by 5. Hollow it is 2 by 3. For a rod at the center it is 1 by 12. So that is the factor which I am talking about in the formula of moment of inertia. So you put half over here. You can take the LCM. This will become mg divided by 2 small m plus capital M, whole thing divided by 2, which is 2 small mg divided by 2 small m plus capital M. This is how easy the formula is. 2 small mg by 2m plus capital M. Exactly, which is option A. Understood? Isn't this a much easier trick? Without drawing free body diagram, without writing torque equation, without writing Newton's law equation, without writing A is equal to alpha R, nothing is needed. Directly only you can solve it. Moving to the next one. A disc is rotating about its symmetrical axis in a horizontal plane at some rate, revolutions per second. You place a coin, the coin does not move, it is at rest. What is the coefficient of friction? See, straightforward question. Straightforward question. If you have a disc, this is the axis of rotation, it is rotating like this with omega, and now you are placing a coin somewhere and you see that the coin is also rotating without slipping. That means the coin is placed at such a distance it is placed at a distance of 1.25 centimeters, it is not slipping, such that the outward centrifugal force, which is m omega square r, is being balanced by the frictional force. And remember, there is going to be normal and there is going to be mg also. Exactly. And this friction, let's say, is limiting in nature, so that it is just preventing it from slipping, because I want to find the coefficient of friction. Okay, it is not slipping. So guys, our Fs max is just going to be the centrifugal force. Fs max is mu into n, normal is mg, right? So from this, mm will get cancelled, mu will be omega square r divided by g. So what is the value of mu? Let's find out. G is 10, radius is basically 1.25 centimeters, so 1.25 into 10 to the power minus 2. The problem is with omega, we can find that out. 3.5 revolutions per second, each revolution is 2 pi radians. So 3.5 into 2 pi radians per second. 3.5 into 2 is 7, so it is basically 7 pi radians per second. So just put over here 7 pi but whole square it. That's it. That is going to give you the value of the coefficient of friction. And solving it, you should get the answer as 0.6. 0.6. That is how you do it. Got it? Simple. Centrifugal force is going to throw it out. Friction is going to prevent it from slipping outwards. Both will balance. That is why it is at rest on the disc. Friction will be mu n is mg, mm cancels, substitute all the values. Omega was in revolutions per second. One revolution is 2 pi radians, so that's why I multiply by 2 pi radians. That's how I convert it into radians per second. Fair enough. Let's try to solve the next question coming up on your screen. A pendulum clock is losing some time when the temperature is this much, and it is gaining some time when the temperature is something else. What is the temperature at which the clock will be showing correct time, and what is the coefficient of linear expansion? So let's see how do we solve this kind of question. Yeah. Sukruti, some more time, hardly few more minutes. That's it. Last few questions are there. See guys, the time period of a pendulum is related to the length, and the length is related to the temperature. So here is the logic behind it. Our time period of a pendulum is 2 pi root of L by G. So the relative change in the time period is half times relative change in the length, because the power of length is half. That's why the half number comes outside. I'm using the concept of error combination. But what is delta L by L? No worries. Remember, change in the length is original length into alpha into change of the temperature, right? So therefore, what will delta L by L be? It will be alpha into delta theta. Great. So hence I will get the relative change in the time period is half times this delta L by L. I will just put it as alpha into change of the temperature. Now this is our main equation which we are going to use for both these scenarios. For both these scenarios. So what are those scenarios? Let's try to figure it out. First time it loses 12 seconds. So basically it loses 12 seconds per day. So delta t is 12. The time is day. One day is 86,400 seconds. This number you should remember. How did I get this number? One day has 24 hours. 24 hours. That means each hour has 60 minutes. Each minute has 60 seconds. So you multiply 60 seconds into 60 into 24. You will get 86,400. Right. So this is basically equal to half into alpha into let's say, you will write it as 40 minus T. Okay, so the temperature which is actually correct will be somewhere between 20 and 40. Somewhere between 20 and 40. So 40 will be bigger than the temperature. So that's why 40 minus T. Similarly, it gains 4 seconds per day. Each day is 86,400 seconds. Half into alpha into this will be T minus 20. Now divide both of them. Just have to divide both of them. The moment you divide both of them, you will get 12 by 4. 12 by 4, 86,400 will get cancelled. Half alpha will get cancelled. 40 minus t by t minus 20. 12 by 4 is basically 3, cross multiply. So 3t minus 60 is equal to 40 minus t. So take t on that side. So 4 times of t, 60 plus 40 is basically 100. So the temperature will be 25 degrees Celsius. So 25 degrees Celsius is only there in option number 1. So I'm just going to mark it, and yes, perfect. If you substitute this back over here, you will get the value of alpha. If you substitute it back over here, you can find the value of alpha also. That is not needed, but if you need it to find out, then you can do it. Is that okay? Nice question, guys. Did you love this question? Yes or no? Quickly let me know in the chat box. Very nice question. This is another question coming up on your screen, and it says, if a gas is undergoing a process from A to B, the maximum temperature in the process will be where? Now I'll tell you what, when you have pressure versus volume diagram, there are isotherms. That means the points where, there are points where you will see the temperature is same. Yes. So it will look something like this. These are the isotherms. These are the points where the temperature is going to be same. This is the point where your temperature is going to be the same. Let me use some thinner lines. So something like this. This one, then this one, then this will make it even hotter. These are basically isotherms. This has high temperature. High temperature. As you go here, this is basically low temperature. Now, as per the question, what does it say, my dear warriors? Read it carefully. The maximum temperature. Maximum temperature will be on this particular curve. So that is basically this particular point. And this is exactly the midpoint. This is exactly the midpoint, my dear warriors. This is 1.5 V0 and this is basically 1.5 P0. Exactly the midpoint. Exactly. And we know since PV is equal to nRT, temperature will be PV by nR. Pressure is 1.5 P0. Volume is 1.5 V0. Number of moles N. R is R. 1.5 is 3 by 2, 1.5 is 3 by 2, 3 3s are 9 by 4, P0 V0 by NR. Wow, this is simple. P0 V0 by NR, 9 by 4 times. That's all that is there in the problem. It will be exactly at the midpoint. How many of you got it? How many of you got it? Very good, very good, very good. Awesomeness. Very good. Great. Guys, why are you getting timed out by the admin? Make sure you are concentrating on the class. You are not come here for dating. This is not a dating website. You can download other apps. Yes, you can download. I'll tell you. If you want, I'll make a separate session. I'll make a separate session. Manoj, everyone, for all of you. If you want all, girls and guys from the same city, same things, I can do a video on that. We'll have a, session, or we'll have a meeting also then. If you want, I'll make. Yes. Yes. Concentrate. Concentrate. Very good. Okay. Let's move on. Let's move on. Let's do the next question coming up on your screen. Here it is. What does it say? Some water goes from 40 to 60. Ignoring expansion, the change in the internal energy is. We all know that to find the internal energy, we can find the heat, because heat is change in internal energy plus work. Because expansion has to be ignored, that means the work done will be 0. So delta U will be Q, and Q is MC delta T. That's it. MC delta T here. Mass is 200 grams. So it is 0.2 kg. Specific heat capacity is 4184 joules per kg per Kelvin. Change in the temperature 60 minus 40. 60 minus 40. Exactly. Solve this. You shall get the value of delta U. Just check if you are getting it as 16.7. 16.7 into 10 to the power 3 joules. Just check this out. Yes. Yes. Cheat code video has already been made. Cheat code video has already been made. Yes. Okay. So you can check that out. I think Navamita ma'am had made that. Yes. Okay. Shall we go to the next question coming up on your screen? Here it is. What does it say? For the PV diagram given below, pressure is constant by volume. This, which of the graph correctly represents in temperature pressure diagram? So this graph in the temperature versus pressure graph will look how? Come on, think about it. Come on, think. Think carefully. What do you think will be the correct answer? Temperature versus pressure graph. Yes. So paper discussion, we'll see if we can have, if we get the paper, definitely we'll try, but I'm not so sure. Okay. D option, pakka? Oh my God. No, it is not D, it is option B. I'll tell you what is the difference between these two. This graph, you can clearly see pressure into volume is constant. That means temperature is constant. Here temperature is changing, here also temperature is changing. So these two graphs are eliminated because temperature is not constant in these two. These two are acceptable, but the problem is you should see the number 1 and 2. You are going from 1 towards 2. So as you go, the pressure is reducing, the volume is increasing. Here the pressure from 1 to 2 is definitely reducing. From 1 to 2, here the pressure is increasing. So this is definitely not correct. This will be correct because the pressure has to reduce from 1 to 2. So that is why option number B. Got it? Why not D? Did you understand why not D? Very good. Very good. Yes. Perfect. Awesomeness. Awesomeness. So Chenna Vijayalata, see if you guys understood this point. Pressure is constant by volume. So volume into pressure will be constant. When is pressure into volume constant? Yes, temperature is constant. It's an isothermal process. P is inversely proportional to V. And when you go from 1 to 2, you can draw the arrow mark. You can see the pressure is slowly reducing till 2. Between these two graphs, when you go from 1 to 2, do you see pressure is reducing? Here, but here from 1 to 2, pressure is increasing. That's why I eliminated it and I selected option B. In these two options, temperature is not even constant. It is changing. So I eliminated these two in the first go only. Next question. Okay. So guys, these kind of questions. The new amplitude of the oscillation will be how much? Come on, think about it. The new amplitude of the oscillation will be how much? Okay. So guys, a mass, when it is in that equilibrium position, okay, you have put another mass gently on it, and you have to find the new time period, the new amplitude of the oscillation. I'll tell you what is the difference in this problem, or what is the thing which will change in this problem. See, basically, because you are putting it gently, you are not exactly doing any work. Okay, you are not changing the energy of the system. You are not taking away the energy, nor are you giving the energy. So if you are placing it gently so that, the mass, starts, or rather the mass increases, because of which the amplitude will change. All you need to do is energy initially will be equal to energy finally. Initial energy, I can say it is half K into basically amplitude square. Half K into amplitude square. Or I can do one more thing. Wait, I can't, instead of doing this, let's do one more thing. The moment I place this mass on this other mass, since the total mass will increase, the velocity will reduce. Think about it, that velocity will reduce. So you can think of it like a collision problem. When the mass is at the equilibrium position, when the mass capital M is at the equilibrium position, the velocity is maximum, remember that, and that maximum velocity will be A into omega, right? Now the moment you place the next mass, the mass, total mass will increase, omega will change, and that's why probably the amplitude will also change. So treat it like a collision problem. Treat it like a collision problem. This mass into a omega will be equal to, this is the initial momentum, this is initial momentum, this is your initial momentum, is equal to the final momentum. The final momentum will be m plus m into this new velocity. M plus m into this new velocity. What will that new velocity be? That will be the new amplitude, I will call it as A1, into the new angular velocity, which is omega 1, which is nothing but omega 1. Let me call it like that. Okay. Now, what is omega and omega 1? Let's find that out as well. Initial omega will be root of k by m. It will be nothing but root of k divided by m. What will be final omega? What will be final omega? Think about it. It will be root of k by m plus m. Root k gets cancelled. From here, I am left with a by root of m is equal to a1 divided by, root m will get cancelled. So root m will remain on the top. So root m will remain on the top. And same thing here also. You will see root of m plus m will remain on the top. That's it. I found out now the new amplitude is nothing but root of capital M by m plus m into our A. That's it. That is the answer. Root of m by m plus m into A. So I have used the conservation of momentum because I have gently placed it. So the initial momentum would have been mv, m into v. The final momentum will be the total mass into that new velocity. That new velocity will be again A into the new amplitude into the new angular frequency. So substituting everything, you will get the answer directly. Yes, perfect, perfect. Awesome. Let's move on to the next question. The potential energy of a particle is given by U is equal to 4 into 1 minus cos 4x. The time period of the particle for small oscillations is, wow, very nice question. Very nice question, guys. Come on, think about it. How are we going to solve this question for small oscillations? Look at it. U is equal to 4, 1 minus cos 4x. This is an equation in cosine. I don't like it right now. So what is the best option that we have? What is the best option that we have? Can we write cos in something else? Or should I think that this is a slightly modified equation of SHM? Should I convert cos into sine? A lot of people might think, sir, I think we should convert cos into sine because generally we don't deal with cosines in SHM. The answer is no, you don't do anything. Just do one small change. You write it like this, 4 minus 4 cos 4x. Okay, 4 minus 4 cos 4x. Oh, but this is not position. My bad. What am I doing? Sorry. This is of energy. So when it is energy, usually we have x square. Usually we have x square. Okay, I can do one thing. Cos 4x, why not write it as cos of 2 into 2x? Cos of 2 into 2x. This is cos 2 theta formula. This is cos 2 theta formula. So now, what is cos of 2 theta? Cos 2 theta is 2 cos square theta minus 1 or 1 minus sines 2 sine square theta. So why not write it as 1 minus minus will become plus 2 times sine square theta. Theta over here is 2x. Theta over here is 2x. Now this one and this one will get cancelled. So our energy will come out to be 4 into 2 sine square 2x. 2 4s are 8. So 8 sine square 2x. But we all know theta is small, then sine theta will be theta. So if x is small, 2x, sine of 2x will be 2x. So this will become 8 into 2x whole square, which is 2 square is nothing but 4. 4 into 8 is 32. So 32x square. This is your energy. But we all know the formula for energy is half k x square. Formula for energy is half k x square. So x square gets cancelled. Our value of the spring constant will come out to be 64 Newton per meter. Once I know the value of k, I can find the time period, which is 2 pi under root m by k. So it is 2 pi under root, the mass is 4, k is 64, 4 goes with 64 16 times, so it will become 2 pi, root of 16 is 4, so it will become pi by 2 seconds. Pi by 2 seconds, that is option 2. Yes, it is option number 2. Perfect. So because it was energy, I realized, okay, wait, I need x square term. If it was x is equal to something, I wouldn't, convert it into sine square and all of that, because equation of SHM is either a pure sine or a pure cosine with some constant terms. That is perfectly okay. But energy is always with x square. Remember that in SHM. What about this? The ratio of the kinetic energy and the potential energy of the body which is performing SHM is at a distance of 1 by nth of the amplitude of the mean position is how much? Okay. The ratio between the kinetic energy and the potential energy. Now, since I know sum of kinetic and potential is the total energy, how about writing kinetic energy as the total energy minus the potential energy, right? Total energy minus the potential energy. So it will become E by U minus 1. Why did I do it like that? Why did I do it like that? The reason is total energy formula is half k a square. Potential energy formula is half k x square. So half k will cancel. I will just get a by x whole square minus 1. Now the value of x is 1 by nth of the amplitude. So this is a by n basically whole square minus 1. A cancels. So it will become n square minus 1. So that is basically C option. That is basically C option. Correct. Very good. Excellent. That is the correct answer. Cool. Shall we go ahead to the next question coming up on your screen? Here it is. This is your EMAT 2005 question. A body is suspended of mass m from a spring like this. This is mass m. This is k. And the change in the position due to an additional force acting on it is how much? If an additional force acts on it, what happens is the spring will get even further elongated before it stops again. It started here and it stopped here, and there is an elongation over here x, and during this while this force was continuously acting. This force was continuously acting. In this process, this force did some work. The work done by that force F, where did it go? Where did you think that it will go? It will go in changing the potential energy of that particular spring. Potential energy of that spring, is that right? So what is the work done by that force? It is basically F into x. What is the potential energy of the spring? It is half k into x square. X cancels. So x will be F into 2 divided by k. F into 2 divided by k. So that is the answer, 2F by k. 2F divided by k. All that work will go into the spring potential energy. Correct. Next question. Two wires same length and thickness are joined one end to the other end. The modulus are in this ratio. The combination is stretched by a load. What is the elongation in these wires ratio? What is the ratio of the elongation of the wires? Okay, I'll tell you what. When you have two different wires of the same length and thickness, so same length and thickness also, only the material is different. Because their elastic modulus is different, their elongations will be also different. But one thing is there, whatever tension is there will be the same. The force will be the same. The force or the tension in that wire will be the same. And we know Young's modulus, think about it, Young's modulus, okay, we'll just put it here. Young's modulus is stress, which is force by area, divided by strain, which is x by L. Okay, great. So let's rearrange this. Let's rearrange this. X will be equal to F as it is. A comes below. L goes on the top. Young's modulus comes below. So X is inversely proportional to the Young's modulus. If force is same, length is same, area is same. Therefore, the ratio of the elongations x1 by x2 will be y2 by y1. Will be y2 by y1. What is y2? 20 into 10 to the power 10. What is y1? It is 15 into 10 to the power 10. So 10 to the power 10 cancels. 20 goes with 5 4 times. 15 goes with 5 3 times. So 4:3 should be the answer. Yes, it is. 4:3. 4:3. Correct. Everybody answer this in the chat box. If you got it, shall we go ahead to the next question, guys? Very nice. Let's move on. Let's move on. Here is the next question. The stress strain curves are given for multiple materials and they are within the elastic limits, which has maximum elasticity or minimum elasticity. Please remember, this is strain by stress. So the slope of this curve, which is strain by stress, will be 1 by Young's modulus. So in fact, in this problem, the one which has more Young's modulus will have lesser slope and the one which has less elasticity will have more slope. It is inversely proportional. So now, using this theory, think about it. Who has the highest slope? P. P has the highest slope, so it has the least Young's modulus. Oh, this is maximum. This is wrong. Who has the lowest slope? Who has the lowest slope? R. So R will have the highest Young's modulus. R will have the highest Young's modulus, lowest slope. Why is it Young's modulus? So why is it not there, guys? I think there is some mistake in the printing or something over here. I think the answer marked over here is D. Elasticity of wire P is minimum. Oh yeah, this is correct. Yeah, this is correct. Right. So elasticity of wire P is not maximum, it is minimum. That is correct, because P has the highest slope. Highest slope means lowest Young's modulus. Correct. This is correct. Perfect. This is fine. Perfect. Lowest Young's modulus is highest slope. You can see P has highest slope. So that's why Young's modulus is low. Perfect. No problem at all. Moving on. If there is a vessel which is filled with gas, temperature, half the mass is removed and the temperature is increased, then the pressure of the gas in the vessel is going to be. Okay, I think it's pure ideal gas equation. PV is equal to nRT. So here in this particular problem, can you identify who is going to be constant and who is not going to be constant? Who is going to be constant and who is not going to be constant? Because it is in a chamber, the volume is going to be constant. R is a gas constant. So I think pressure is directly proportional to N times the temperature. Even the moles is not constant because some of the gas is removed. So guys, I can say P2 by P1 is N2 by N1 into T2 by T1. Therefore, final pressure by initial pressure was 10 atm. The number of moles second time will be half. So it will be 1 by 2 ratio, because final mass will be half times the original mass. Final temperature is 87 Celsius. So 273 plus 87. Original temperature was 27. So P2 by 10 is equal to half into, this will be plus 780 and plus 80. 360 divided by 300. 0 cancels. This goes with 6 times. This goes with 6 5 times. So 2 5s are 10. So 10 cancels. So I am just left with 6 atm. Yes, 6 atm should be the answer. Let's check it out. Yep, 6 atm is the answer. 6 atm is the answer. Perfect. Yep. Number of moles will become half. Why did it become half? Because half of the mass was removed. Exactly. Moving on to the next question. A ball is released in a liquid of a different density. What will be the acceleration? Because the densities are different. Okay, so if this is the ball and it has certain mass, certain density, certain volume, it will have its own weight mg downwards. The buoyant force will be upwards, which will be V into the density of the liquid is sigma into g, and the result of all of this is it's going to accelerate. The solid has more density than the liquid, so it will go down like this. It will sink. So using Newton's law, I can just say mg minus the buoyant force, which is V sigma g, is equal to your mass into acceleration. Bigger force minus smaller force is mass into acceleration. I don't want mass, I don't want volume, I want only density and g. Great. So what I can do is I can just write the volume, this particular volume. Understand what this is. This particular volume I can write in terms of density, because density is mass by volume, since that means volume is mass by rho. So I will just put, instead of volume, mass by rho, and rest of the things will just get carried forward. Sigma is there, g is there, m is there, a is there. Is that right? So what happens? M gets cancelled, g comes out as common, and I will have 1 minus sigma by rho is equal to a. Therefore, a is equal to rho minus sigma by rho into g. Rho minus sigma by rho into g. Yes, that is option number 3. That is perfectly fine. I just got rid of volume here, because density is mass by volume, volume is mass by density. Substituted it over here. Rest mass got cancelled, and it is very, very straightforward after this. Correct, everyone? Simple. Let's move on to the next question. If a bubble is at the bottom and it is going up in a liquid with some constant speed, the density of the air is neglected. The coefficient of viscosity of the liquid is approximately. You have to neglect the density of the air inside. That is the main thing. That is very important. And this is a question on terminal velocity. It's a bubble and it is going in some liquid. Is there a formula for terminal velocity? Yes. What is that formula? Because it is going with constant speed. The formula for terminal velocity is 2 by 9 r square, and then you have g, here you have eta, here you have the difference of the densities. So rho minus sigma or sigma minus rho. So in this particular problem, the terminal velocity is 0.25 centimeters per second, but centimeters is 10 to the power minus 2 meters. 2 by 9, radius 1 centimeter, so 10 to the power minus 2 meters square. G is 10. Difference of the density, air's density is neglected, the liquid's density is 1.5. grams per cc will make it 10 to the power 3 kg per meter cube. The whole thing divided by eta. That's it. Solve this, you will get the value of eta. Just solve this, everything is known, you will get the value of eta. The answer comes out as 130 approximately. 130 Pascal seconds. Exactly. That should be the answer. Why is it a question on terminal velocity? Because it is going, it's a sphere which is going inside a liquid with a constant speed. Instead of falling down, it is going up. That's the difference, because the bubble has lower density than the medium. Generally, the drop falls down because the density of the drop is more. But if the drop was lighter than the outside medium, instead of falling down, it will rise up with terminal velocity. That's the only difference. Okay, so 130 is the answer. Okay, so you have a homework question. Make sure you solve it and post the answers in the comment section. Cool. So I hope you guys enjoyed a lot and you learned a lot from today's class. All the best for your EAPCET examinations, all the Telangana and the Andhra students, and do really well. And whatever more sessions we can do, we'll try to do it, okay, on this channel. So that's the reason why you stay subscribed. Bye bye. This is Captain Shreyas signing off. Hasta la vista.